All right, everybody, welcome to Lesson 5A in Pre-Calc, and we're going to take a look at some trig functions, and this starts our trig odyssey in this particular term. We've got a lot of review to do to make sure you're in good shape. All of what you've seen today, I assume you've seen before, but just to be on the safe side, we're going to just go ahead and run through this real fast. Want to remind you of the angles in standard position to start, and positive angles, you go counterclockwise, sort of like this positive angle right here. Start on the positive x-axis and then sort of rotate that way. Negative angle goes the other direction clockwise. Coterminal angles are two angles that have the same initial side and the same terminal side. So, for example, if this angle alpha right here were 135 degrees, it would be the same thing as saying negative 225 on the other side. They're coterminal. They have the same measure. So, for example, in this little picture on the far right here, if this one had a measure of 45 degrees, well, then all you have to do is add another 360, another revolution around the coordinate plane to get to 405, and those two would be coterminal angles. Okay, so just a quick little refresher on that. You'll probably be asked on the practice problems to name a couple of coterminal angles. Adding and subtracting 360 is always a good move there. Okay, so converting degrees to radians. That one you might recall if you want to convert 71 degrees into radians, then you have to multiply by pi over 180. Pi over 180. So I'm just going to do that in a calculator really quick here. And when I do that, I get about 1.239 radians as an estimated amount for that. And you could do the same with 35. I'm going to skip over that other example. I want you to try it yourself and see what you come up with. Converting pi over 10 into degrees, well, you have to multiply by the reciprocal, so 180 over pi. So pi over 10 times 180 over pi. Well, the pi's are going to wipe out, and you're going to have 180 divided by 10, which is just 18 degrees. And then 2 pi over 3. I'll go ahead and spot you this one. This should be easy for those of you who remember your unit circle. That's equivalent to 120 degrees. Okay, so I'm not going to really spend a whole lot of time on what's down here at the bottom of the page. That's a whole lot of button pushing. But I do want to talk a little bit about this thing called trig inverses. And an inverse function is basically going to name the angle. Okay, the trig inverse function is going to name the angle. So if I tell you that the sine of something is 3/7, then in your calculator you're going to type in sine inverse of 3 divided by 7. And it's helpful if you remember that we are in degree mode here. That's something to watch out for. So it might not be a bad move to maybe check your calculator by hitting the mode key really quick before you do this. So if I type this into a calculator, which is unfortunately off screen and you can't see it, you're going to get about 20, oopsies, wrong tool there. There we go. You're going to get about 25.4 degrees. Okay, and you'll find some interesting things for the cosine inverse of 1/2. My guess is you'll probably see that's going to be 60 degrees. And the tan inverse of pi over 4, I'm going to let you guys play with that and see what you come up with. And again, I want you to just, maybe spend a little time doing some button pushing here on the examples up above. If you want to do these 4 examples that I'm going to highlight right now, the E, F, G, and H, what you want to do is make sure your calculator is in radian mode, although for the 0, I suppose it really doesn't matter. 0 radians and 0 degrees are obviously the same thing. Okay, so on to the next slide here. And as we continue this look at the trig functions, you know sine, cosine, and tangent. Unfortunately, that was only half the story. So you were probably really mad at your geometry teacher when you found out that we had these other functions of cosecant, secant, and cotangent. But the nice part about those three is that they're just reciprocals of the first three. And I'm going to show you this little picture here and show you how to do the other problems that are like this. So for example, if you've got a side links or if you've got a coordinate plane that where you can know that a point passes through on a terminal side of an angle like, I don't know, 3, 4, for example. Let's just call this point right here, we'll call this 3, 4. Okay, well that means you can just go ahead and draw yourself a right triangle with a height of 4 and a base of 3. And knowing that it's a right triangle helps because then you can quickly determine that that hypotenuse is 5. And now you can start the process of naming all of the different trig function values because you've got them all right here. If you just know your SOHCAHTOA, then what you can do is write out the others in a hurry. So let's just go ahead and maybe draw a picture of a triangle here. Something really quick that I could do. Oh, maybe I won't be able to on this. Crud. Well, it'll just be a very poor picture. We'll just turn it into a right triangle even though it doesn't look like such. And if you know that the sine of an angle is 5, 6, we'll pick any angle and call it theta, and then you know that the sine is the opposite over the hypotenuse. And if you go ahead and do the Pythagorean theorem to get that other side, you end up with the square root of 11. So now what you can do is, now that you know that the sine is 5/6, you can say that the cosine of that angle theta is root 11 over 6. And the tangent is going to be 5 over root 11, opposite over adjacent. So, you know, just a quick little rehash right there on those things. Opposite over adjacent, adjacent over hypotenuse, opposite over hypotenuse, excuse me, for the sine, opposite over adjacent for the tangent. Now, I wouldn't rationalize the denominators right away just yet. And the reason why I wouldn't want to do that is because you still have some work to do on getting the other three. So let's start out with the cotangent because that's going to be really easy to do. It's just the reciprocal of the tangent. So it's just root 11 over 5. And then the secant is going to be the reciprocal of the cosine. So it's going to be 6 over root 11. And then you have the cosecant, which is just the reciprocal of the sine, also known as, well, let's see, it's 5/6, so the cosecant's got to be 6 over 5. Then at that point, you go ahead and rationalize and get any radicals out of the denominator. So the tangent here would be 5 root 11 over 11, and the secant would be 6 root 11 over 11. Kind of a crummy way for me to write this, but we're sort of running out of room here. All right, so that is a quick little review of that. You can try this problem right here real quick. Find the sine and the tangent if the cosine is 2/7 and the cotangent is greater than 0. Oh, okay, well, that's a nice little clue to have, knowing that the cotangent is greater than 0. If the cosine and the cotangent are both positive, then everything else is going to have to be positive as well, which is good news. So you just need the sine and the tangent. All right, so maybe draw yourself a little picture here. Again, this doesn't have to be perfect, but a quick application of the Pythagorean theorem will tell you that that opposite side is square root 45, also known as 3 root 5. Okay, so now you can go ahead and do the sine of angle theta, which is going to be 3 root 5 over 7. And then you can do the tangent. Let me get a little bit of room here. The tangent of that particular angle is going to be 3 root 5 over 2. Okay, so pretty easy to do. You just draw yourself a little picture, get the triangle in there, and put the parts in and see what you can do to get the rest. Okay? All right, so moving on down here to the bottom very quickly, we've got these lovely little reference triangles which help us get exact values of some famous trig functions. You might recall that on your reference triangles on the 30, 60, 90, if the short leg is 1, then the hypotenuse is 2, and the longer leg is root 3. And then in this 45, 45, 90 over here, you know the two legs are congruent, isosceles triangle, two legs congruent. If they're each 1, then the hypotenuse is root 2. Okay, so a quick little refresher on that. Now what you can do is go ahead and see if you can find the sine of 30, which is going to be 1/2, and the cosine of 30, which is adjacent over hypotenuse. So that's going to make that root 3 over 2, and then the tangent is just going to be 1 over root 3, and then you'll rationalize that one to root 3 over 3. And then from there you can get the others pretty quick. So the cosecant's 2, just the reciprocal of the sine. Secant is 2 over root 3, and the cotangent is going to be root 3 over 1, or just root 3. So this rationalizes to 2 root 3 over 3. And it's going to be really helpful for you to make sure you know these values pretty well. On the 45, 45, 90, it's a little bit easier. Sine and cosine are going to be the same thanks to the whole nice little congruent, or excuse me, isosceles triangle thing. So both of these are going to rationalize to root 2 over 2. And tangent is just going to be 1, so is the cotangent. And believe it or not, the secant and the cosecant are going to be really easy to get. Really, really easy to get. Okay, so the cosecant is just going to be the reciprocal of the sine. So instead of opposite over hypotenuse, it's going to be hypotenuse over opposite. So that's just going to be root 2, and so is the cosine. Okay, so again, quick introduction here into reference triangles and how they can really help you evaluate trig functions quickly. It would be really smart for you to have all of these values memorized. If you don't, then your chance is coming in the unit circle, as I'm sure you already figured. So off to the last slide for one more example. Okay, so at this point I'm just maybe going to do 2 more quick examples here. When we talk about solving a right triangle, that means all the angles and sides. We want every possible bit of measurement that we can get our hands on. So if you need to draw a picture to do this, by all means do so. All right, so we've got a right triangle with right angle at C. Again, it doesn't have to work, it just has to do the job. So here's C. That means A and B can be in any particular order. This doesn't have to be to scale or perfect. Typically we use capital letters for angles and lowercase letters for sides. And so that's the given information there. And now we just have to fill in the chart with the rest. And, well, I'm going to write this in because remember that these sides, this lowercase a that's 15, it's going to be opposite angle A. So you can see I already didn't do this to spec, which is okay. I didn't quite do it to scale, but, you know, it's not the end of the world, which is a good thing. So what you can do is you can come up with, well, let's see, you're going to have to work to get this other side here, but lucky for us it is just the Pythagorean Theorem, so it's 10 squared plus 15 squared is equal to c squared. And then let's see here, so that's going to be, what, 325 is equal to c squared. So you take the square root of 325, that's going to give you your answer, which is going to be about 18.02. So C is about 18.02. All right, well now how do you get these angles right here? Well, I'm going to go ahead and get angle A using some good information. And if I want angle A, I have the opposite and the adjacent. So in order to get angle A, I'm going to do a tan inverse because opposite and adjacent makes the tangent. So angle A is going to be the tangent inverse of 15 over 10. And again, make sure your calculator is in degree mode before you do this. So tangent inverse of 15 divided by 10 is about 56.3 degrees. So there's that. And then what we've got next is we're just able to come up with the fact that if you take 90 minus that 56.3, you're going to get 33.7. And that's angle B. Now why 90 degrees? Because all three angles of a triangle add to 180, as you may recall, and 90 of it's taken up there. So 90 and 56.3 leaves that 33.7 for the remaining angle. Okay, so that takes care of solving that triangle. So let's go ahead and do one quick example here that's on the notes, and then we'll call it good. From a point 340 feet away from the base of the Peachtree Center, a really tall building if you've ever been to Atlanta, kind of a circular glass building that you might remember if you've been there. Angle of elevation to the top of the building is 65 degrees. Find the height of the building. Okay, so you've got this distance of 340. So you are here. Hi. And then we have a really, really, really tall building here. Okay, so again, not to scale, you just know that's 65 degrees. Okay, so to assume that that's a right angle to make your life a little easier, and then you notice that that height of the building is the opposite side, and this is the adjacent side. So if that's the case, then you know you're looking at a tangent, and it's the tangent of 65 degrees is equal to h over 340. So now it's an equation, and you can just multiply both sides by 340. And you can get this into your calculator in one nice clean keystroke here. And you're going to find out that the height of the Peachtree Center, at least according to this problem, is 729.13 feet. That's a really tall building. Okay, so that's what I've got on this. Go ahead and maybe try this other problem that's down here at the bottom. Talk it over with your friends and neighbors, and then tackle your practice problems.